In this SQL challenge, we're going to learn how to solve a hard difficulty problem called consecutive days from Salesforce. This is actually not a super difficult problem, but it requires a bit of knowledge about window functions and the gaps and islands technique. If you're not familiar with the gaps and islands technique, it's a SQL pattern used to identify consecutive sequences in data. The islands are groups of consecutive records, like consecutive dates, while the gaps are the breaks between these sequences. This technique is particularly useful when you need to find streaks or consecutive patterns in your data. Now, let's look at the description here. The problem is really straightforward. Find all the users who are active for 3 consecutive days or more. And we're given a table called SF events that contains user activity records with account ID, record date, and user ID columns. Since the problem is only focusing on find the users who are active for 3 consecutive days, we'll primarily be working with the user ID and record date columns. To solve this problem, we need to identify consecutive date sequences for each user. The key thing here is using a technique called gaps and islands. When dates are consecutive, if we subtract a row number from each date, consecutive days will produce the same result, effectively grouping them together. To solve this problem, let's select the distinct record date and user ID from the SF events table to eliminate any duplicate entries for the same user on the same date just in case. Now we'll add the row number window function partitioned by user ID and ordered by record date in ascending order. Let's code the output as row number. This assigns a sequential number to each activity date for each user. Next, we need to calculate a day's offset. We'll take our row number, subtract 1, and multiply by an interval of 1 day. This creates an offset that increments by 1 day for each row. And to get the group day, subtract the day's offset from the record date to create a group day. For consecutive days, this will produce the same group date value. That's what allows us to identify consecutive activity. And don't forget to sort the data set by user ID and record date. Now let's run the query to see what the output looks like. From the output, if we look at user U1, we can see a great example of how the group date identifies consecutive days. For the first 2 rows of U1, the record dates are December 8, 2020 and December 9, 2020. Notice that both rows have the same group date of December 8, 2020. This is because these are consecutive days. When we subtract 0 days from December 8, 2020, the date remains the same as December 8. When we subtract 1 day from December 9, 2020, we also get December 8, 2020. The matching group dates tell us these are part of the same consecutive sequence. Now looking at user U4, which shows an even clearer pattern. Rows 2, 3, and 4 have record dates of January 10th, January 11th, and January 12th. All 3 of these rows share the same group date of January 9, 2021. This indicates that U4 was active for 3 consecutive days, which is exactly what we're looking for. Now let's wrap this entire query with a common table expression, or CTE, called dataset. This will make our final query cleaner and easier to read. Now that we have our CTE, let's write the main query. We'll select user ID, group date, and use the count aggregate function on group date to count how many consecutive days each group represents. Let's call this date consecutive count. Then we'll add a group by clause for user ID and group date to group our consecutive date sequences together. Now let's run the query and examine the output. Looking at the output, we can now see each unique consecutive activity streak for every user. The day consecutive count column tells us how many consecutive days each streak lasted. Notice user U4 with group date January 9, 2021 has a day consecutive count of 3. This means U4 was active for 3 consecutive days, which meets our requirement. Finally, we need to filter for only the users with 3 or more consecutive days. We'll remove the group date from our select statement since we only need the user ID in our final output. Now, instead of using a where clause, we'll use a having clause because we're filtering based on an aggregate function. Check the output to ensure solution is correct. Once you are confident with the answer, click Check Solution, and the system will mark the problem as solved. And that is everything I am going to cover for this SQL challenge tutorial. I hope you guys find this video useful. Feel free to post your question in the comments below. And don't forget to like the video and subscribe. Happy coding. See you in the next one.